Welcome everyone to our derivatives unit. So the opener that I want to ask is, what is a derivative at a point? More generally, what is a derivative of a function? Well, you should be able to answer the first question. What is the derivative at a point? Well, it is the slope of the tangent line at that point. So for example, here we can see that the derivative is going to be the slope of this red line. But more generally, what's the derivative of a function? Well, that's kind of interesting. It actually is a function that when we plug into it, it can give us the slope of any tangent line at any point on the function. And that's going to sound really confusing right now until I give you some examples, and we're going to jump into that. All right, so here's some answers. The derivative at a point is the slope of the tangent line at that particular point. A more formal definition is f prime of a, which is the derivative of a function f at point A, is the slope of the curve y equals f of x at the point where x equals a. Close that parentheses. This is the notation that means the derivative, or the slope of the tangent line at x equals a. This is going to make a lot more sense once we use it a ton. If you like that formal definition, go ahead and write it down. This is what we really care about during this particular lesson. The derivative of a function is an equation that determines the slope of the tangent line at any point x. So for example, if f of x equals x cubed, then f prime of x equals 3x squared. So the derivative of a function is actually an equation, and we'll be able to plug into that equation to find the slope of the tangent line at any point x. So it's much more useful in general than finding the derivative at a point. Now certainly this is a little confusing right now, but I promise you it's going to make more sense as we start doing concrete examples. This is the formula that you've seen before, but now I'm going to add the word derivative to it. So remember, in section 2.4, we define the slope of the curve y equals f of x at the point where x equals a. To have a slope m of the tangent line defined as this. We've seen that. That's just the slope of the tangent line at your point A. However, now I'm introducing this word derivative. When it exists, this limit is called the derivative of f at a. So in this section here, we're going to investigate the derivative of a function by considering the limit at each point, every single point of the domain of f. So we're going to get a more general answer. Again, you're still probably a little bit confused because this is conceptual, but it is going to get more concrete. All right, the derivative of a function. To this point, we've only found the derivative at a point. Wouldn't it be nice if we could find a derivative function that would tell us the slope of the tangent line for any point x? Sorry about that, I got a phone call. All right, so the derivative of a function f with respect to the variable x is the function f prime whose value at x is the following, provided the limit exists. This should look exactly like your other formula, except notice that instead of an a, we're putting in x. Instead of an a, we're putting in x. And this makes total sense because before we were just finding the derivative at a point, x equals a. Now I'm going to find the derivative, or the slope of the tangent line, for all values of x, given that it's in the domain. All right, finally, let's do an actual problem and really think about what this means. This is going to put everything together for you. So find the derivative of f of x equals 2x squared. So the question's saying, find an equation that's going to give you the slope of the tangent line for any point that you want. All right, so we're going to have the limit as h approaches 0, and instead of putting in a plus h, I'm going to put in x plus h right in there. So I'm going to have 2 parentheses x plus h squared, right? I'm just replacing this x with x plus h. Now, minus, and now you can think about putting an x in for every single thing. Or, what is f of x? Well, literally, f of x is this right here. So if I'm subtracting f of x, I'm just going to minus 2x squared, because f of x is this. All right, and this is all going to be over h. All right, so now we're going to go ahead and do FOIL, and you certainly can do this on your side, but I'm hoping you can start to do FOIL in your head. This is going to be 2, and this is going to be x squared plus 2xh plus h squared minus 2x squared. And I'm thinking now maybe I need to show you how to do that. So this is going to be an x plus h times an x plus h. So x times x is x squared. X times h is an xh. Okay, that's first and outer. Now I'm going to go inner, which is h times x, or just another xh. And then h times h, which is my last, is going to be an h squared. Well, there's 2 of these, so that's an x squared plus 2xh plus h squared. So exactly what I have written here. All right, now don't forget this is all over h. Next step that we're going to do is we're going to go ahead and do our distributive property. So let me erase this to give myself some room. You guys, there's a fly. It just won't leave me alone. I'm pushing through it though. All right, so this is going to be a 2x squared. See, I'm doing this first one. Plus a 4xh plus a 2h squared minus a 2x squared all over h. And what you see happening here is that everything's going to cancel out except for things with h in it, which is really good. So my 2x squared and my minus 2x squared disappear. So this is going to be the limit as h approaches 0 of a 4xh plus 2h squared over h. So now I'm going to pull out an h. So it's going to be the limit as h approaches 0. Pulling out an h, I'm going to have a 4x plus a 2h all over h. So now my h's cancel out. And now I'm left simply with the limit as h approaches 0 of 4x plus 2h. Well, I'm only putting 0 in for h. So I'm putting the 0 in here, and that's going to get me an answer of 4x. So we're going to answer, our final answer is going to be f prime of x equals 4x. So our answer is actually a function. So the question is, what does this mean? So just as a reminder, what we just did was we took the function 2x squared and we got the derivative of 4x. Well, let's go ahead and find f prime of 0. We pronounce that prime. So we're taking the derivative of the function at 0. I'm going to take this 0 and I'm going to plug it in, and 4 times 0 is going to give me 0. What does that mean? Well, let's go ahead and look at x equals 0. That means that at x equals 0, the slope of our tangent line is 0. And it totally is, isn't it? Right? This is a slope of m equals 0 because it's a flat line. Let's go ahead and let's try another one. Let's try f prime of 1. So f prime of 1, we're going to go ahead and we're going to plug in 1 into our f prime of x function, our derivative, and we get 4. Okay, what does that mean? That means that our slope of our tangent line at x equals 1 is 4. And let's see if I can actually do that slope up, rise 1, 2, 3, 4 over 1. So we're saying that we've got a tangent line that has a slope of 4, and that's correct. So what we have found is something so valuable, and we'll talk about implications in the next unit, in our applications unit. But this function basically allows you to plug in any point, say f prime of -2, plug that -2 into your derivative, and you found that at x equals -2, right up here, the slope of that tangent line, ooh, that's a bad tangent line. The slope of that tangent line would be -8. And so you have found the slope of the tangent line for any x value that you want on this graph. So I'm hoping that that kind of gives you an idea of what a derivative is, what a derivative function is. All right, I'm going to call that good on this video, and I'm going to do a few more calculations on how to calculate this in the next video. There's going to be a square root one. I highly recommend watching it because I do think it's going to trick you a little bit. All right, that's it for video 1. Thanks for watching.